Hi guys, Dr. B here. This is the average atomic mass and isotopes and relative abundance lecture. So let's talk about certain vocabulary first before we can get into what we're supposed to cover. So the atomic mass is the mass of an atom and is obtained by finding the average mass of the isotopes of a given element. So what is an isotope? You should have learned about this in biology, but an isotope, it refers to atoms with the same number of protons but have different numbers of neutrons. Relative abundance is the percentage of atoms with a specific atomic mass found in a sample of that particular element. So how do you designate an isotope? So you can say, for example, carbon 12 or C12. The carbon indicates, the C indicates it's carbon, the 12 indicates the number of protons and neutrons combined together. You can have a carbon 13, so that will be C13. This actually should be, hold on. Yeah, anyway. So if it's C13, it'll be 6 protons and 7 neutrons. You can have, for example, carbon 14 and nitrogen 14. It's the same mass number, but because they're different elements, they have different atomic numbers or number of protons. There's also another way to designate this. We have the symbol of your element. So like hydrogen, for example, the 1 on the bottom is the atomic number, and the number on the top is the number, is the mass number. So that means that we'll talk about different types of hydrogens in a bit. So let's compare the following. We have carbon 12, 13, and 14. It tells us that we have 6 protons, same number of electrons, I'm sorry, but different number of neutrons. So how are they all alike? They have the same number of protons and electrons. If you change the number of electrons, it is considered an ion. How are they different? You have different mass numbers and different number of neutrons. So let's look at these. We have the symbol copper 6429. So the atomic number of copper, it is 29. The mass number is a number at the top, so that is the 64. And so for copper, the number of protons, it is 29. And the number of neutrons is 64 minus 29. It's going to be 35. So similarly, you can fill out this chart again. So we have the number of protons and the number of the atomic number is the same, so 79 and 79. The number of neutrons is given to you on the bottom. So the number of the mass number is the number of neutrons and protons, so it's 197. So we have the 79 here. We have a 197 at the top. So which element has an atomic number of 79? And it's going to be gold. So A. So read this, think about it, discuss with yourself, I guess, if you're watching the lecture. What are the values of W, X, Y, and Z? So we can see that W is the number of neutrons here. So for this chlorine, it gives us a mass number and a number of protons. So remember that the proton number plus the atomic number plus the number of neutrons would give us the mass number. So it would be 18. Chlorine X, the mass number is X according to this thing. So then 17 plus 19 neutrons is going to be 36, so the answer should be B. Hydrogen has 3 naturally occurring isotopes, protium, deuterium, and tritium. So you can see that each of them have 1 proton, but some number of neutrons are different, hence the different isotopes. So stable isotopes are isotopes with a long half-life. Half-life is defined as the time it takes for a substance to decompose and reach a concentration or weight that is half of its initial. Some examples are carbon-12, 13, oxygen 17, 16, and 18. My bad. Radioactive ones have short half-lives and degrade quickly. They emit radioactive waves when they do so. So tritium, which is an isotope of hydrogen, and carbon-14. So here are a bunch of ones that are relevant to medicine. So if I give you a list, you're probably going to have to know these. So cobalt-60 is radiation therapy to prevent cancer. Iodine-131, brain tumors, monitor cardiac, liver, and thyroid activity. Carbon-14, diabetes, gout, anemia to study metabolism changes. Carbon-11, it is used in a PET scan to target glucose to monitor organs. Sodium-24 is used to study blood circulation. Thallium-201 determines damage in heart tissue and detection of tumors. And technetium-99, that's TC, locates brain tumors, damaged heart cells, or radio tracer in medical diagnostics. So it's used to image organs and blood flow and all that. How to calculate average atomic mass. Step 1, identify the percentage of each isotope in the composition of the element and its mass. For each isotope, multiply its mass by the percent, add the results, and then you'll get the average atomic mass of a given element. Example 1. Calculate the average atomic mass of boron given that 19.8 of its naturally occurring atoms have a mass of 10.013 AMUs and 80.2% have a mass of 11.009 AMUs. I could give you a question where it's going to be, this is an unknown element. What is the, based on this average atomic mass, what is the element? Some other questions, which we'll cover later, you are going to have to determine the percentages. So that could be something you need to know as well. So 10.013 times 0.1918 plus 11.009 times 0.802. I just move my decimal over twice to the left, take these decimals. So I do my math. So I got 2.0811 AMUs, which is the one that we get on our periodic table. Example 2. Average atomic mass of copper given. It gives you percentages in the AMUs, same concept. So 62.93 AMUs is related to the 0.691 plus 64.93 times 0.309. Oh my gosh, I'm so sleepy. $63.55 AMUs. All right, that's it for now. Let me know if any questions. Thanks. Bye.